Now we're going to configure virtual router redundancy protocol or VRRP, which is closely identical to HSRP. But VRRP is a standard based protocol which is alternative to the HSRP. VRRP defined in RFC 3768 and it use a term like master and backup, which is same as active and standby gateway. And rest of concept going to be the same, like selection of active router and sending hello messages and using authentication and so on and so forth. But it used their own transport protocol using multicast address 224.0.0.18. Obviously the virtual MAC address going to be different than HSRP. Print is enabled by default in VRRP. Actually that makes sense. And one more thing would like to discuss about VRRP. You can use physical IP address as a virtual IP address. So let's say if we have two devices like gateway 1 and then gateway 2, it's going to connect with ISP on right hand side and left hand side going to connect with the LAN. So the IP address of gateway 1 LAN interface is 10.10.10.1, 10.10.10.2. In HSRP we cannot use 10.10.10.1 or 10.10.10.2 as a virtual IP address for a gateway. But in VRRP it is possible. So we can use either IP address 1 or 2, which is already configured to the interfaces. But if we going to select the physical IP address use as a virtual IP address, the device which has configured already that physical IP address going to become a master. Because my IP address is 10.10.10.1 and virtual IP address which we going to configure 10.10.10.1, automatically it creates or it change priority to 55. So print is enabled by default. So gateway 1 device going to work as a master. If it goes down, then after it is taken care by some other gateway. So this is the weird thing which I find in VRRP. So you can use physical IP address as a virtual IP address. Obviously load sharing can possible like HSRP. Using particular interface we can configure into multiple groups. And using multiple group we can perform load sharing. There is 3 versions of VRRP, VRRP version 1, 2 and 3. VRRP version 3 also support IPv6. Now it is the little bit discussion of the technical detail of VRRP. Now we are going to implement it on topology. So I have the same topology where I have multi-layer switch 1 and multi-layer switch 2 and the rest of devices which is connected to the LAN side, and this is going to the virtual IP address 10.10.10.254. So configuration going to be the closely identical to HSRP as I told you earlier. So before going to configure VRRP, let's check where we have connectivity to the internet or not. Yes, we do have. And on switch 2. Great. So the configuration is straightforward using interface VLAN 1 which is connected to the LAN, VRRP, then after VRRP group number, and as we can see the rest of parameters is closely identical to the HSRP like IP address and so on and so forth. So IP address going to be 10.10.10.254. And one more thing I would like to mention, in VRRP it's going to send hello messages out every 1 second. So that's why very soon it become a master device because none of device is sending me hello updates. So I am the single person who is supposed to work as a master. So let's configure same thing on switch number 2, interface VLAN number 1, VRRP group 1 and then virtual IP address 10.10.10.254. So print is enabled by default, so we can see switch 2 going to become as a master. So in case of HSRP, we need to execute a command like primsen enable. But in case of VRRP, which is already enabled. So since switch 1 has IP address 10.10.10.1 and switch 2 has IP address 10.10.10.2, and priority both have the same. Excuse me, both gateway has the same priority. Switch 2 going to on that virtual IP address and virtual MAC address and actively forward traffic to the internet. And let also verify who is working as a do so VRRP, who is working as a master. So currently I am working as a backup, and virtual IP address is 10.10.10.254 like virtual MAC address, and I'm going to advertise out every 1 second. Primsen is enabled and priority is the same as HSRP, which is 100. And master router is 10.10.10.2 and priority is 100 because priority going to tie up, but your IP address is higher than my IP address. That's why you're going to be work like a master router. So next thing which I like to show you, suppose if we're going to use so let me disable first, no, and similarly no. So currently my IP address is do so IP interface brief, in section include only F1/0 or 1/0. No, it is actually the IP address assigned under VLAN 1. So VLAN. So as we can see on switch 1, the LAN IP address is 10.10.10.1, which is the physical IP address or physical interface assigned IP address. So what happens if we're going to use this IP address in HSRP? So HSRP is standby group 1 and then IP address 10.10.10.1. We cannot use, as we can see, the address cannot equal interface IP address. But in case of VRRP, we can use the physical IP address, which is 10.10.10.1. So once we enable 10.10.10.1, we also going to change the default configuration. Let's see, do so VRRP. My priority is 255. It is no longer as 100. So similarly, if we're going to configure on this device, VRRP group 1, IP address 10.10.10.1. I'm going to work as a backup, and it is going to work as a master because switch 1 priority is 255 and switch 2 priority is 100 only. Do so VRRP. That's why switch 1 going to actively forward traffic toward the internet. So just let me change and do as we decide, which is VRRP group 1 and virtual IP address should be 10.10.10.254. Likewise here, no VRRP group number 1 virtual IP address 10.10.10.254. So now switch 2 going to work as a master because it going to work as a default configuration, which is do so VRRP. My priority is 100 and switch 1 priority is also 100, but my IP address is higher than switch 1 IP address. So let's check whether host have connectivity to the internet or not. Yes, we do have. We can also trace route for Google public DNS server. So I'm sending data 10.10.10.2, not to 10.10.10.1, which is switch 1. One more thing I would like to mention right there, we can also use IPSLA, as I told you in previous video. So suppose if your layer, you can track layer 1 status and layer 2 status. and sometime if you may connected with the DSL router, from you to DSL, or it may be connected to the switch, maybe layer 1 and layer 2 is up, and even then you not have a connectivity to the internet. So maybe you are connected with the switch, obviously your physical layer going to be up and data link layer going to be up, because keep live message is going to send from the DSL router or a switch. So if you want to check at application level connectivity, like using ping or using some other feature, you can use IPSLA in order to track the correct information of internet connectivity. So for example, let's see, we're going to configure on switch number 2. So currently I'm working as an active, do so VRRP, as we can see, not active actually, it is master. So here I'm going to use IPSLA monitor track number 1. Under monitor, we're going to use type is echo and protocol going to be IP ICMP, and please check the connectivity from Google public DNS, and it is belong to the source IP address also use, or source interface address my VLAN 2, which is connected to the WAN. So the configuration is send a ping message to this destination using my source IP address, whatever IP address assigned to my VLAN number 2, which is connected to the internet. Next thing is IPSLA monitor. We need to schedule this. Schedule entry number 1 and start time now and lifetime forever. So forever you're going to send ping messages, and let's see this, what is the current status. So IPSLA monitor statistics. So we send a ping message to the Google public DNS server, which is 8.8.8.8. We get reply back successfully. So let also use this using track. So what I'm going to use track interface and use RTR or response time reporter along with entry number 1 of IPSLA and check reachability. If we do have a reachability, then I'm going to attach it with VRRP. Either you can attach with GLBP and HSRP as well. So let's see the status of track. So track. So in track 1, we're going to check RTR1 for reachability, and reachability is up. So same thing we can apply for interface VLAN number 1, VRRP group number 1, use track object number 1, and then decrement my priority, let's say 20. So currently we do have an internet connectivity, that's why everything is okay and happy. And let's say the configuration, do so VRRP, we tracking object number 1. If we do not have internet connectivity, or maybe let me add a switch right there, put right there, excuse me, and disconnect this one and connect with, this is interface F0/1 to the switch. So as we can see, our data link layer and physical layer going to be up, but we do not have a connectivity to the internet. So your IPSLA going to track it. If we do not have internet connectivity, I am going to decrement my priority, which is from 100 minus 20, so going to be 80. So since the first thing to figure out who is going to work as a master is your priority. If priority tie up, then highest IP address. In my case, if my IP address going, if my priority going to less than from switch 1 going to actively forward traffic toward the internet. So let's say what is going on. Now we can check. So IPSLA monitor and statistics. We getting a failure message. Similarly, we can show track. As we can see, it become a backup router, backup gateway, sorry, and switch 1 going to become as a master one. So likewise, we can apply the same thing on HSRP, VRRP and GLBP. So it is what known as IPSLA. I think we have already discussed about the IPSLA. So let me fix it out, or let do as it is. One more thing would like to discuss about load sharing. So obviously load sharing is possible. Let's say we're going to create two group 1 and group 2. Excuse me, group 1 and group 2 on both devices. So for group 1 we have default IP address 254. We can also put 253 for group 2, and that IP address we can assign to this device. So for group 2, host 1 is serving by group 2 and host 2 is serving by group 1. So at same time both devices can be up and working. So as we can see, so let me connect it back to the appropriate interface, which is interface F0/1 to the my switch. Excuse me, switch is there. So interface F0/0 to the switch interface 2. So there we go. Now what I'm going to do, going to perform load balancing. So on switch 1, let me hop over to the VRRP, interface VLAN number 1. VRRP, since we getting reply back, since switch 2 getting reply back, now it's going to become master, and switch 1 again going to become as a backup. So VRRP group number 1, and then group IP address going to be 10.10.10.253. Likewise on this one, configure terminal interface VLAN number 1, VRRP group number 2, and IP address going to be 10.10.10.253. For group 1, switch 2 is actively working. For group 2, I am going to make switch 1 to forward data to the internet, or make as a master router. So VRRP group number 2, priority going to be, let's say, 200. So as we can see, now switch 1 going to forward traffic, actively forward traffic to the internet for group number 2. But what we need to do, we need to change the default gateway of these devices. So let me change the IP address of gateway as well. So let's say host 2 going to configure IP default gateway 10.10.10.253. So let's check whether we do have a connectivity to the 10.10.10.253. Yes, we can also trace route to the internet 8.8.8.8. Trace route 8.8.8.8. So host 2 sending data from switch 1, and host 1 should be send data from switch 2. So in such a way we can also perform load balancing using HSRP as well as VRRP. But in upcoming section we're going to see it is enabled by default in GLBP. So let's see the rest of things, which is on switch 2. Let's say VRRP group number 1. So authentication is possible, description that we can do rather than name. In HSRP there was a name, IP address, print, priority, shutdown. You can shut down VRRP timers, you can change the timer and tracking. So I'm not going to configure these all these things since we have already discussed in HSRP. But yes, we need to discuss about VRRP version 3, which I'm going to configure it in upcoming section, where we're going to perform IPv6 first hop redundancy protocol. So in this video, so far we have discussed VRRP, or a virtual router redundancy protocol. So the difference is, in VRRP we can use a physical IP address as a virtual IP address, and we changing the concept from active to master and standby to the backup. Obviously the IP address going to be changed as well as the MAC address, and preemption is enabled by default. So this is all about this video.